Hi, everybody. I'm Marlon Pierce, and along with my colleague Suresh Maru, we're going to be teaching an I-590 special topics class on Science Gateway architectures, open source distributed computing this spring 2016 semester at Indiana University. This short slide presentation is going to provide you with an overview of some of the things that we're going to cover in the course and tell you what you're going to get out of it. I would add also, the big logo here at the top is for Apache Aravatha, so we're members. Suresh is the official board representative of the Apache Aravatha project to the Apache Software Foundation. So there's a payoff for that at the end of the slide. So again, this is a background for an I-590 special topics course. The first link here is the official page link for the course. And then you can also go to this shorter link down below it and find the same material. So you go there and you'll find the official course description. So again, in these slides, I want to give you an idea of what the course will cover. We have three goals. First goal is to teach some basic distributed computing concepts by applying them to science gateways. So let me say a little bit about science gateways. These are web tools and desktop tools that use distributed computing concepts to manage scientific applications and scientific data sets that run on supercomputers, clouds, clusters around the world. So we like to try and understand how distributed computing is actually done in practice at the unprecedented scales that Google and Facebook, Amazon, and other companies like that do it. Of course, the screenshot here, or the picture, is a Google data center from about 4 years ago. And Google and these other companies are doing things at scales that were unthinkable, even a decade ago. And a lot of it is based on core distributed computing concepts that have been taught for years. Not all of it, but a lot of it is, and a lot of it is really proving what works at scale and what doesn't. We're really interested in building academic web scale systems that build on those lessons. So those are, goal number one is, say, more theoretical. Goal number two is more in the lines of what you might call design patterns at scale and development methodologies at scale. So what architectures, methodologies, and technologies work to build systems like this? The example architecture that you can look up more information on, and which we'll be exploring in this class, is called microservices. And these are extensions and new versions of older ideas like service-oriented architectures, component-based architectures, other things like this. So here, there are not necessarily right and wrong ways of doing things, but there are choices and trade-offs. And so this is maybe more of a design pattern than a strict mathematical, theoretical approach to computer science. For methodologies, we have DevOps, which you probably have heard of, and that is essentially that your development team and your operations team are all one, and maybe not just that you have an operations person sitting next to a software developer, but that those roles are shared by all members of the team. So you don't just write software, you don't just run systems, you know how to do both. And of course, technologies, there are too many of those interesting things to look at to mention. A lot of these technologies, whether you're talking about NoSQL databases or cloud computing systems, things like this can be used to build science gateways. Finally, goal number three, what you'll get out of this class is an understanding of how open source software is governed, how to follow open source software practices. So you may be familiar with GitHub and other tools like that, services online for managing your code and for tracking problems and communicating and so forth. Those are all important building blocks, but on top of that, you still have to have human beings making decisions about where the code is going, what directions, what architecture, what solutions. If there's a patch that's contributed, who accepts it, when do we do a release, all those sorts of decisions are part of governance. And the Apache Software Foundation, the feathers, of course, the Apache logo, is a organization that helps open source projects figure out how to govern themselves. So we'll be covering the Apache way in this class. We won't be directly contributing to Apache projects yet, but we'll show you how Apache works. And, I think you put all these things together and you're going to really distinguish yourself from your peers who are going to have resumes that look a lot like yours. And by the end of this class, you're going to have code publicly available with an audit trail of communications about how that code got to be the way it was and how that code can be operated without extensive documentation, where it can be easily deployed, run, proves itself. All these things will be an outcome for you from this class. So the structure of the course, students will be put into development teams. The team will be responsible for end-to-end systems. You'll be writing software to develop systems, but you'll also be running them and showing that they work. Each team will develop open source science gateway system from scratch. It's not be a full-fledged system, of course. That's a pretty ambitious thing, but we will be implementing a prototype system from scratch. There'll be bi-weekly assignments, and grades will be primarily based on your projects. So the projects will either directly or indirectly contribute to all the grades. There'll be, of course, presentations associated with projects. Each assignment will illustrate one or more distributed computing topics, and students will learn how to operate services as well as write good software. And finally, you will learn open source methodologies. So one of the potential payoffs here is that as members of the Apache Software Foundation, we have access to Google Summer of Code slots. We're always looking for good students. And one of the things we'll be doing in the course, if this is a topic that is resonating with you, is to work with you to develop a GSOC 2016 application for the Apache Arvata project. And we'll also show you how to do this for other Apache projects. So when you come out of this, if you are an excellent student, then you're going to, and are interested, you're going to have a Google Summer of Code project. And you're also going to lay the foundation for future GSOC projects, either with us or with other Apache projects. So the deadline for this is March 25th. I realize the logo here is for 2015. The new 2016 logo isn't available yet. So more information is available at this URL. And feel free to contact either of us if you want to learn more about the class. You can also jump on the Arvata mailing list if you're interested in seeing how these systems work in the real world. And also, we welcome you to check out the Apache Arvata website. Thanks very much.